Hello everyone, this is Terry Vinson with Micronics Training, and today what we're going to do is we're going to explore some of the components behind using the UCS B-Series system. Specifically, I want to focus on the idea of being able to do a fiber channel boot process. Now, we're going to be looking at this purely from the point of view of the UCS. We're not going to be delving too deeply into, say, the MDS side of the house. However, I will show you what happens on the MDS with regard to zoning and with regard to how to verify that my devices are doing what I want them to. And also we're going to explore it from the point of view of the SAN. The SAN POV is not part of the CCIE data center preparation track. However, I think it's important for us to be able to look at the storage array and make certain that we understand exactly what's happening when it comes to the configuration of these systems. What we see right here is the UCS B-Series client software. I'm using UCS version 2.1 for the purpose of walking through each of these different elements. Now, before I can really do anything, the first task is I need to build a service profile. Now, there's a few things I want to verify, because what I'm going to do is I'm going to want to use one of my servers. Specifically, what I'm going to use is I'm going to go to the Equipment tab, and from the Equipment tab, what I am going to do is I'm going to hit the plus sign here, and I'm going to go to my chassis, and I want to look at my servers. As you can see, inside of chassis 1, I have 8 servers. These servers are going to be servers 1, 2, 3, 4, 5, 6, 7, and 8 by numbering. Now, specifically, what I'm going to do is I'm going to focus on server 1, because server 1 is the one that I'm going to apply my service profile to. So I'm going to create a service profile, and that service profile is going to do a remote boot process. Now, this remote boot process is going to be involving fiber channels. So we're going to be using VHBAs to accomplish this task. Specifically, I'm going to create a VHBA for SAN Fabric A, and I want to create one for SAN Fabric B. Now, we can make this very complicated, or we can make this very simple. So what I'm going to do for the purposes of this walkthrough, I'm going to do a very initial introduction to setting up this idea of fiber channel boot capability using the service profile. Not going to do anything fancy. In fact, what I'm going to do is I'm going to manually specify a lot of the values. We're not going to use any templates. We're not going to use any updating or initializing processes. We're simply going to create a service profile, and we're going to apply that service profile to this blade, server 1, and what we're going to do from there is we're going to walk through everything necessary to get this blade to be able to boot from the target that we're going to be setting up in the SAN storage array. So right now, what we're going to do is we're going to explore the configuration of the UCS just a little bit more, and that means we are going to take a closer look at this server. So I want to look at server 1, and what you're going to see here is in server 1, there's going to be some key elements that I want to pay attention to. First of all, I want you to notice that the server state is available. Now, the server needs to be available before I can assign a service profile to it. A lot of people get really concerned because I may give a student a blade to use for class, and the student may not be able to apply a service profile to it, and one of the reasons for that is that it could be actually running a service profile from another student or from a previous engagement, i.e. a lab that you've done. So just keep in mind that this server is mine, and I'm going to only be able to associate one service profile to this blade at any given time. Now, with that, what we're going to do is we're going to take a look at what's involved in this process, and that means we're going to need to take a look under the Servers tab, because that's where I create my service profiles. Now, just to keep things organized, what I'm going to do is I'm going to create a sub-organization. Now, I'm going to call that sub-organization Instructor Demo. So I'm going to right-click, I'm going to say Create an Organization, and I'm going to call it, as I said, Instructor-Demo. I'm going to hit Enter, and what you're going to see here is this is going to create a sub-organization under which I can keep all of my configurations separate from everyone else's configs. Now, as we look at this, as we go through what's happening here, that means that that instructor demo suborg is going to be visible under my LAN tab. In fact, you guys should be able to see it here under my policies. So you can see now I've got instructor demo here. I also have it under my SAN tab. So what we're going to do is we're going to begin creating things necessary to help me build my server. Now, again, we don't need to do a lot of this. However, there are some things that I want to create that's going to make my life a little bit easier. First, I'm going to create two pools. I'm going to create a UUID pool, a universally unique identifier pool. And I'm going to use that to assign to my service profile so I don't have to use the UID that's going to be associated with the specific blade. Remember, UCS is all about stateless computing, which means we do not want our applications to be bound to the physical hardware, because what that would do is that would limit our capability of being able to relocate a service profile or a server from one device to another if I were to lose a blade. So just keep in mind, I'm going to use this. The other thing I'm going to do is I'm going to create a pool of MAC addresses that I'm going to experiment and work with. So first, what we're going to do is, as I said, I'm going to go under the server's configuration here, and under my suborgs, it's very difficult to not do it under root, just out of rote. But notice I have this idea of a UUID suffix pool. So I'm going to right click on it and I'm going to create UUID suffix pools. I could have gone over here and clicked the plus sign. It's just I don't like moving my mouse around very much. So what I'm going to do is I'm going to call this Terry's UUIDs. And what I'm going to do is I'm just going to simply hit enter. And I'll create a set of UUIDs. And what I'm going to do is I'm going to call this one 1010, and I'm going to create a pool of, let's say, 32 of these. And I will finish. Now what this is going to do is I'm going to be able to use this bank of UUIDs that I just created. I'm going to be able to use this bank to assign to my service profiles as I create machines. Now I'm going to only create one, but I just want to have a pool of them available. The other place that I said I was going to create a set of resources was I'm going to go under suborgs, under the LAN tab, and I'm going to create a pool of MAC addresses that I'm going to apply to my IP VNICs, my virtual network interface cards. So what I'll do here is right click and say create a MAC pool, and I'm going to call it Terry's MAC pool. And what I'm going to do here is I'm going to create a block of addresses. Again, I'm going to create 32 of these. And I'm just going to use them for everything, so I'm not going to be very specific about this. What I am going to do is I'm going to put in here that this is going to be the numbering sequence that I'm going to use, and I want to start at 1. And I'm going to hit OK, and what this is going to do is that's going to create a block of MAC addresses that I can now assign to devices. So if I come over here to my MAC pools under instructor demo, highlight this, we can see the MAC addresses that I have created, and you can notice that they are not assigned to anything at this point. Now obviously, when we create a service profile, we're going to modify or change this output, and we'll take a look at that when the time comes. So right now I've created my UUID pool, I have created my MAC address pool. Now it's time to actually create the service profile, and to do that we're going to take the path of least resistance. So now the time's come for us to create that service profile, and what I'm going to do is I'm going to go to servers, and under my suborg, what I'm going to do is I am going to create a service profile. Now what I'm going to do is here under the configuration I'm going to say right click, and what I'm going to do is I'm going to select create service profile expert. Now what this does is this is going to allow me to do a little bit more than I could if I were just using the basic or the introductory wizard. So in expert mode I can do a number of things. I can have more than 2 VNICs, I can have more than 2 VHBAs. I can carry multiple VLANs on a VNIC interface, i.e. I can support the concept of a trunk, something that you can't do in the basic config. But what I want to do is I'm going to create 3 Ethernet interfaces ultimately, and in order to be able to expedite that process, I'm going to do that via this concept of the expert service profile wizard. So click here, and what I'm going to do is I'm going to give this a name. I'm going to say Terry _remote _boot service profile, call it 1, and I need to give it a UUID. So all I'm going to do is I'm going to hit the down arrow, and I'm going to select that pool of UUID addresses that I defined. Next, I'm going to go through and hit the next button, and that's going to take me through this list of things that I have to do in order to configure a service profile. The very next one is going to be networking. Now, from the networking configuration, notice I have Ethernet 0 and Ethernet 1, but if I want to carry more than one VLAN, I need to be able to use the expert config. So right now I'm going to click over to expert, even though I haven't created any additional VLANs. And what I'm going to do is I'm going to create three VNICs. So I'm going to call the first one Ethernet 0. I'm going to use the MAC addresses from the pool that I specified. And I'm just going to go ahead and put the default VLAN on this VNIC, and this VNIC is going to be part of Fabric A. I'm not going to worry about failover right now. And I'm not going to really pick anything else that's part of the configuration here. I want to demonstrate just how simple this is. So I hit OK, and you can now see that I've created this virtual network interface card. I'm going to create two others. The next one is going to be Ethernet 1. Again, this is going to be for Fabric B. I'm not going to worry about failover. I'm going to put the default VLAN, which is VLAN 1, on it, and I'm going to use the pool of MAC addresses that I created and hit OK. And then lastly, I'm going to create that third virtual network interface. I'm going to call it Ethernet 2. Again, I'll pull from the pool of addresses that I set up. I'll select just the one VLAN that we have, and this time I'm going to say this is going to be for Fabric A, but I want to enable failover. Now what this does is this means that the network card that I'm using in the server will detect if there's a failure, and it will actually move me over to Fabric B in the event of a failure of Fabric A without really notifying the software installed on the server. So for instance, if I put ESXi on these devices, that's going to hide that problem from that installation. So again, I'm just going to hit OK. And again, keep in mind that I'm focusing on the bare minimum requirements to make this operate. Yes, we have quality of service mechanisms, we have policies, we have a number of things that we can define and configure on the system, but I want to demonstrate just how easy it is. And after that, after we've mastered just getting everything to work, then what we're going to do is we're going to focus on manipulating the values used by these different devices. A lot of people tell me that they take the CCIE lab exam and everything was working. Well, it's very easy to get everything working, especially in the confines of the UCS. However, when those same students have said the UCS was completely working, my vSANs were up, everything was operational, and they come back and they tell me that they failed, if everything was working, if that's a true statement, it tells me that they missed some critical element that were being required to do that made the system work in just a little bit harder than the basic method. So as I'm going to show you, without applying quality of service mechanisms, I'm not even enabling jumbo frames, what you're going to see is the system is actually going to be able to find that remote target, and what we're going to do here is focus on the simple. So with that, I've created my three VNICs. Notice my fabric is Fabric A for VNIC or Ethernet 0. It's B for Ethernet 1. And notice that for Ethernet 2, the one that I'm going to use later on to provide an alternate method of booting, is going to be both for Fabric A and for Fabric B. Now notice, right now, there's a value down here that we haven't really utilized, and that's going to be add a iSCSI VNIC. Now, we are doing a fiber channel boot process. Now, if I wanted to do iSCSI, what I would do is I would create the iSCSI VNIC. Now, we will do that. We'll definitely entertain it. But right now, what I want to do is I want to just get a service profile up and working using the concept of the fiber channel configurations. So what we'll do now is hit next and go to the concept of setting up storage. One of the things that really trips students up when it comes to storage is the fact that we have to be so specific. Remember, when we set up virtual network interface cards, we used MAC addresses. Those MAC addresses were assigned via a pool in this particular demonstration. And those VNICs are the equivalent of network interface cards. When it comes to storage, we have host bus adapters, or HBAs. And when it comes to the UCS, we emulate or virtualize those using VHBAs, virtual host bus adapters. Now, host bus adapters come with addressing. That addressing is going to be the way that we make reference to the device. So the component or the address that is the equivalent of a MAC address, roughly, when it comes to the idea of SAN, is going to be what we call a worldwide name, a dub-dub-in. Specifically, we have dub-dub-in-ins for node names and dub-dub-p-ins for port names. Now, again, the big thing here is that a lot of students get wrapped around the axles when it comes to using these because we have to be specific. Because it's using these dub-dub-p-ins that I'm going to determine who can speak to whom. So for instance, I have server 1 in this UCS. There are 7 other devices in the chassis. They could be servers that are used by other students. How do I prevent a student that is not me from using my target drives? Well, I use dub-dub-p-ins in concert with a feature called zoning to be able to create specific lists of the devices that can communicate with each other. So I take the dub-dub-p-in of my VHBA, and I take the dub-dub-p-in of my target drive that I'm going to be writing to in the drive array, and I put them in a zone such that I am creating the equivalent of an access list, meaning any device that's any 2 devices or more devices that are inside the same zone can talk to each other. So what we want to do right now is let's see what's going to be involved taking the shortest path to get a functioning service profile. So what I'm going to do is I'm going to, first of all, do something other than local storage. And what I'm going to do is I'm going to say create a specific storage policy. Now, the mode of the specific policy is going to be by default any configuration, which means notice any of these values would fit. However, I could say any device that has RAID or any device that is running specifically no local storage and other combinations, but any configuration is going to be ample for the task that we're looking to implement. I'm also going to use expert mode rather than simple mode, just simply because I did it on the VNIC configurations. So dub-dub-in-in, well, I didn't configure a pool, so what I'm going to do is I'm just going to manually enter one. So what I'm going to do is I'm going to pick the format here of using 2.0. And what I'm going to do is I'm going to type in that I want to use 201A. And what I'm going to do is I'm going to say 0025 B5110001. Now that that is entered, I could verify whether or not this is available, and it currently is. That prevents me from entering duplicates. But what I want to do now is I need to create the VHBA itself. So what I'm going to do is I'm going to hit add here. And under the add, I'm going to create VHBA-A. Now this is going to be the virtual host bus adapter that's going to go to my Fabric A side of my drive array. And I need to give it a dub-dub-p-in. And that dub-dub-p-in is very important because, again, remember, it is going to be how I do my zoning. Now, what we're going to do here is inside the confines of here, I did not create a pool, nor do I want to use any of the hardware components. So what I'm going to do is, again, I'm going to manually enter a dub-dub-p-in. So I'm going to say 201A 0025 B5 110101, and that will be it. This is going to be for Fabric A, and it's going to be in vSAN 11. Now notice the max data field here is 2048. So this is automatically going to support the fiber channel protocol that we're going to be setting up. I'm not going to define any adapter policies or any QoS policies. Again, I'm taking the path of least resistance. Now I created a fabric for A. I also want to create a fabric for B. So I'm going to call this VHBA-B. And again, I did not specify a value, so I'm going to enter a dub-dub-p-in, and this one is going to be 1B because it's for Fabric B, 0025 B5 11, sorry, 00B5, got that wrong, 25. So it's going to be 25 B5 11 01 01. And that's going to be for my fabric B side, and fabric B for me is going to be vSAN 12, and I'm just going to hit OK. Now what you see here is I have my two virtual host bus adapters all running under the WWPN that I manually specified here. These values are more important for my lab specifically because I'm not doing anything with the WWNNs when it comes to the MDS. We could, but right now I'm just focusing purely on WWPNs, worldwide port names. So let's go ahead and take the next step. From here, what I do is I'm going to say next, and what that's going to do is it's going to ask me if I want to create any zones. Well, we are operating our fabric interconnects in their default end-host virtualization mode for storage, which means we don't need to worry about zoning. We're going to learn zoning from the MDS that we're connected to. So this is something that I can just bypass. Yes, I could mess with it, but right now, again, we're focusing on the simplest path to get a working service profile applied to a blade. So again, I'll just hit next and go through that. And then I also can look at it, something referred to as VNIC placement. Now, VNIC placement allows me to be able to assign virtual network interfaces to physical interfaces that are associated with the mezzanine card as part of my blade. We only have M81KRs in my lab, which means I only have one VCon, one virtual connection. So placement really isn't going to do anything for me. So what I'm going to do is I'm just simply going to hit next. So that's two screens that we get to bypass because we are not employing any fancy features or demands. However, Cisco could have specifically said assign interfaces to particular VCons, and if we did not do that, even though the system works, we could still have failed this particular subsection of the lab exam. So again, right now we're just focusing on getting things up and running. We'll get more details later on, and the main goal here is just to recognize that it's not really complicated to get one of these devices up and running. So now what we're going to do is we do need to pay attention to the boot order. Well, what I'm going to do is I am going to come down and say create a specific boot policy. Now, what will end up happening here is I want to, first of all, boot from my CD-ROM. After that, what I'm going to do is I want to boot from Fabric A. So I'll double click that. And what this is going to do is VHBA is going to be my primary, which means that's where I'm going to be sending my data unless something in the path of Fabric Interconnect A dies. Then what I'll do is I'll switch over to Fabric Interconnect B. Now, once I've got that done, I need to specify what is referred to as a target. Now, the target is going to be what device in the storage array that I need to reach in order to install software or boot from software that's been previously installed. So as you can see right now, I need a value. I need a LUN. I need a logical unit number. Now the LUN is going to be assigned. Cisco will tell you what LUN to use in the exam. And if you are setting up in a live environment, obviously it's important to note that your SAN team is going to give you all the proper information. I know the information. We're going to be using LUN 0, typically used for a boot scenario. And I also know the WWPN of my target. So when we go in and do the configuration here, it's going to be relatively simple. LUN 0. My target is using the number 2100001B 3205 1B A3. Now let me double check that. That should be 2100001B 1B 323205 1B A3. So yes, that is correct. Now HBA B, and what I want to do is I want to configure the system such that I can add one B A3, and it should be primary. So now we've got it correct. So we can see here VHBA A is going to use this target, VHBA B is going to use this target. The only time I will ever use VHBA B is if something should fail in the path for VHBA A. So with that done, what we're going to do now is find out that we can pretty much shoot through most of this. Maintenance policy, I'm just going to use the default maintenance policy that we have configured. Notice the reboot policy here is immediate. I could have been tasked to change that, and we'll look at how to do that. And now what I'm going to do is I'm going to assign this server to server 1. Now if my server is not available in this list and available servers is checked, that means it's being used by some other element or the server has been decommissioned. So right now I'm going to hit OK or Next. Not going to worry about any other policy, so I hit Finish. And now what you're going to find is I'm going to create this virtual server through the use of the service profile concept. So you can see here it is configured. So I'm going to hit the plus sign. And what's happening now is it's going through the process of associating the service profile with the blade that I specified when I did the configuration. Now we can track this using something called the Finite State Machine tab, the FSM tab. So if we look at this, we can see my service profile is 98% applied. However, the server is only 34%, 37 now. What this means is the fact that the service profile is a virtual construct. They typically will operate way faster than, say, something like physical equipment. The actual server itself is a physical device. It's a B200M1 server plugged into slot 1 of chassis 1. So we have to wait for everything to synchronize and come up and become operational. Now what I'm going to do is I'm going to, rather than make you guys wait for this entire process, I am going to step out and I'm going to let this process run, and then once the service profile is associated, the server is up and running, what I'm going to do is I'll come back and then I'm going to show you how to turn the server on. And what we're going to do is we're going to verify whether or not our fiber channel configuration is the way we want it to be. Okay, about 5 minutes has passed, and as we can see, the server is at 100%. We can also tell very quickly that the service profile is also at 100%. Now, the power on state that's configured for this system was on, so the server should not only have applied the service profile, it should have also went ahead and booted. So let's verify that. So what I'm going to do is I'm going to go to the General tab for the service profile, and what we're going to see here is notice that the service profile is assigned, it's associated, and the desired power state is up. So what we're going to do is I want to KVM into this machine and see exactly what's happening. And if I remember correctly, there should be a ESXi install currently running on this device itself. So let's see what ends up happening here. And sure enough, I see the ESXi install. Let me go ahead and drag this up a little bit so everyone can see. And we can see right here, if I hit return, I have my config. So right now, this is actually booted. Now it's configured to do DHCP, and right now that's not the configuration that we're operating with. I'm going to go ahead and give this an IP address so that we can recognize it. So I'm going to say root NXOS12345. That's the default password we use in class. And what I want to do is I want to give it a manual IP address. So I'm going to come down here to configure management network, and what I'm going to do is I'm going to give it an IPv4 config. Instead of using DHCP, I want to set a static IP address so that I can recognize this machine. So space, come down here and give it an IP address, and what I'm going to do is I'm going to say 192.168.10.1. Since this is server 1, I'm going to give it a /24, 255.255.255.0, and a gateway of 192.10.10.254. So basically, I'm just giving it a fake set of addresses that we're going to use. They're not live on the network. I just want to be able to use this to recognize this device. So right now I'm going to apply changes. I'll escape. And as we can see, the IP address has been assigned. Now, I'm going to use this to be able to recognize the server out of a crowd. But I just demonstrated exactly how easy it is. Now, I could have gone through and done the installation of ESXi, but I had already done the configuration here, and I don't want to waste a lot of time in this particular video. Now, the other point that I want to call into place here is there's other ways that we can reach these devices. So as an example, I just demonstrated fiber channel, but one of the things that just scares students to death is the idea of iSCSI. And honestly, from the point of view of the UCS B-Series servers, iSCSI is not that hard at all. In fact, let's go ahead and delve into iSCSI and see exactly what's involved. What I'm going to do is this. I'm going to turn my server off. So I'm going to shut my server down. And hopefully that server will turn off. So let's see what's going on. So right now, notice my server is down. And what I'm going to do is I want to disassociate this service profile. So in other words, I want to say I don't want this service profile associated with server 1 and chassis 1 anymore. Now the way that I do that is I go to the actions window here. And if I scroll down, what you're going to find is I have a section here that says disassociate the service profile. I hit yes. And now what should end up happening is it should turn blue. And if I come up here now, notice it says the state is down. It is unassociated and it is currently unassigned. And the server is going through its thing. It's going to be doing a series of boots and reloads. So if I come over here and check this, notice the service profile says it's 100%. The server doesn't have any value because there's no server associated with the service profile. I want to go over to the equipment and look at server 1 under chassis 1. And let's look at its finite state machine. And what you're going to find here is that it's probably still doing some stuff in the background. Notice right here, it's in the process of removing the service profile that I associated with it. Again, trying to illustrate the fact that the software is really, really quick, but we actually have to wait for hardware to physically do things like reboot, purge information, change information, things along those lines. So just keep in mind that this is still going, and we may have a problem here where it's going to take a little bit longer than I want it to actually go through all of its motions and the mechanisms of removing this association. But while that's happening in the background, let's go ahead and look at another way to get this service profile to work using iSCSI. In fact, I'm going to be a little cavalier. So what I'm going to do is I'm going to go back to the servers tab. What I'm going to do is I am going to erase the VHBAs. So I want to get rid of VHBA B, and I want to get rid of VHBA A. So now I have absolutely no configuration that is storage related on these devices. So I don't use the local drive, and if we look at the configuration here for the service profile and I start looking at my boot order, notice it still wants to try to boot off of those VHBAs through the use of the targets that I specified. But now there's no virtual host bus adapter for me to be able to employ to reach the storage array. Now what I'm going to advocate here is I want to go ahead and use iSCSI to be able to implement that. And that's why I created Ethernet 2. So if I look at the service profile configuration here, notice we have Ethernet 1, which was for SAN A, Ethernet B, which was for, sorry, not SAN A, but Fabric A and Fabric B, and Ethernet 2, which we actually configured for Fabric A, but it has failover enabled on it. So what I want to do right now is I want to convert this system over to use iSCSI as a boot process. And what I'm going to do is I'm going to point it to the exact same drive in the array that I use for fiber channel, demonstrating the fact that I can connect via fiber channel, do the installation, and I could just as easily, as I did in the lab, delete the virtual fiber channel interfaces and go ahead and employ iSCSI to reach the exact same target, provided the array is set up properly, and mine is. So what we're going to do now is I am going to go to the implementation configuration, and what I'm going to do is I am going to specifically select Ethernet 2 to use for iSCSI. However, there's one caveat to this. I need to create a VLAN. So I'm going to create a VLAN, and that VLAN is going to exist on all of my devices. So what I'm going to do is I'm going to create VLAN 55, because that's the iSCSI VLAN. So it's going to be my iSCSI VLAN, and it is going to be global, and I'm going to say that is VLAN 55. I'm not using any private VLAN configuration, so that's not something that I need to worry about. And I just selectively created it, and VLAN 55 should now be available in the system. So a way to verify that is now that that VLAN is created, what I want to do is I am going to make some other modifications and configurations. So right now, I need a way to boot. Well, notice, remember I pointed out the iSCSI vNICs? We didn't create one. What I want to do now is I'm going to make one, because what happens is the iSCSI vNIC actually is going to be the equivalent of a template. Now, I'm talking about like a service profile template. I'm talking about an overlay. So what I'm going to do is I'm going to overlay characteristics that I'm going to use for iSCSI on top of one of my Ethernet connections. The one I specifically picked was Ethernet 2. Now, the idea here is that I could have used it on others, but it is a recommendation to, if you do use it on a Ethernet interface that is not specifically built for this purpose, that you should use it on like the last interface in your group. And that's going to ensure that it doesn't interfere with things like ESXi or ESX. So what we're going to do now is we're going to go through the configuration, and I'm going to call this particular interface, what I'm going to do is I'm going to call it, let's see, I'm going to call it iSCSI vNIC. And I'm going to pick an interface that I want to overlay that on top of. It's going to be Ethernet 2. Now, I'm not going to set any SCSI adapter policies, but what I am going to do is I need to specify a VLAN, but notice that VLAN 55 is not present here. Well, there's a reason that VLAN 55 is not present here. If I go down to Ethernet 2 and I take a look at the config here, I'm going to hit cancel, we'll come back to this. If I go down to Ethernet 2 and I take a look at the config here, and I look at the VLANs that are currently running, the only VLAN that I see is VLAN 1. So what we want to do is we want to modify that configuration. So what I'm going to do here is I'm going to specify VLANs. There, modify VLANs. I'm blind, I apologize. 0. And I am going to make my iSCSI VLAN native. So let's go ahead and hit this. And now that VLAN should appear here. So now what I'm going to do is I'm going to go back up to my vNICs, and what I'm going to do here is I'm going to say create the vNIC, and I said I was going to call this my iSCSI-vNIC, and I wanted to overlay it on 2, and now I should be able to pick my iSCSI VLAN, and I'm just going to go ahead and actually, the recommendation here is since that I'm going to be using this as an overlay for Ethernet 2, I do not pick a MAC address. So what we do is we say SCSI, and now what I've done is I've created this configuration here. So now I have a SCSI vNIC that I'm using for the purposes of being able to implement the iSCSI config. Now, I've picked my overlay. All right, I didn't modify my adapter policy. I could have. I defined the VLAN. I did not set up a MAC address. So now what I want to do is I want to go to my service profile, and what I'm going to do here is I'm going to go to my boot order. Now in the confines of my boot order, what I want to do is I want to look at some things. So first of all, I want to get rid of the storage config that I did earlier. So I'm going to say save changes. So the storage is now gone. So what I want to do now is I want to use this iSCSI VNIC that I created for the purposes of booting, and what I need to do is I need to specify the boot parameters. So this is going to be divided into two primary sections. I'm going to have the initiator section, and then I'm going to have the target section. The initiator is the information that's going to be associated to my server. The target obviously is going to be the iSCSI information, the IQN information, and the IP addresses that I'm going to need to reach the drive array's target. So all I'm going to do is I'm going to do the implementation here. So I'm not going to specify any authentication policy, and I'm going to specify an initiator name, but I'm going to just specify it manually. So when it comes to server 1, I know that my IQN, so my IQN.2016.01.com pod 1. That's the name of my initiator that's been set up on the array. Now, the initiator address, I need to specify an IP address that I'm going to use. For this device, that address is going to be 192.168.55.1 with a /24 mask. I'm not going to worry about gateways and DNSs. Again, we're taking the path of least resistance in this configuration. And now I should be able to take a look at the idea of the target. So the target information. So I hit + over here to create a target. Now that target has a name. Now my target name is IQN.2016.01.com.pod1.target. That's the name that I'm using. Not going to specify any port numbers other than what was created by default. No authentication profiles configured, but I do need an IP address. So where is that target located? It's located at 192.168.55.254, and I'm going to be using LUN 0. So I hit OK, and now what I've done is I've just created a iSCSI boot process that's going to hit this target, this IQN located at this IP address targeting LUN 0, using this address to identify myself in concert with this initiator name. So if I hit OK and do the configs and I hit save my changes, so now what ends up happening is the finite state machine should be percolating. Actually, I need to reassociate. So it's down, it's unassociated. So what I'm going to do is I'm going to change my service profile association. I'm going to manually pick server 1. Hopefully it's in the list and available now. It is. So my machinations took long enough for everything to time out. I hit OK and I hit yes. And what we're going to do is we're going to wait for this service profile to associate. And then what I'll do is I'll turn it on. So I'm going to bow out right now for this process, and again I'll come back when it's done. That way you guys don't have to wait for it, and we'll walk through this process, and if I got all of my sums right, I should be able to hit the target that I specified, and I should be able to bring up ESXi with the proper IP address that we configured earlier. Remember, I used that .1 address. So I'll see you guys once this process is accomplished. All right, our service profile is now applied and booting. So if I were to go back over to the finite state machine tab, we see the service profile is 100%, and we see that the server is 100%. So what I'm going to do now is I'm going to wait for it to apply, and what I'll do while I'm waiting is go ahead and connect via the KVM, and I want to see what comes up when this device boots. So right now, hopefully everything's going to be good to go, and we should see that ESXi install that we saw previously. Now it's just an issue of waiting, and what I'm going to do again is I'm going to bow out, and then I'll come back in when and if the system boots. So I'll see you guys then. All right, about 10 minutes have passed, and the application here, as you can see, it has actually loaded. Now I just have a iSCSI array on a 1 gig connection, so obviously if it was faster it would be a lot more productive, so it wouldn't have taken as long. And it's also important to understand that we're hitting the right target. But how do I really know that I'm hitting the right target? Well, what I'm going to do, just to verify that, is I'm going to go to the virtual media, and what I'm going to do is I'm going to load up my install media. So I'm going to say add an image, and I'm going to go to my OneDrive where I keep all of my stuff for class, and I'm going to connect to the share here, and what I'm going to do is I'm going to pick the ESXi version 6 installation media, and I'm going to map it. And what I'm going to do is I'm going to come over here, and I'm actually going to shut my server down, and then what I'm going to do is I'm going to restart that server, and I want to see what the software discovers. So will that ISO see the right disk? Now specifically, I should have 2 physical disks located inside of the B series server. I should also be able to see pod 1's target all the way through the FI, through the 5Ks, the VPC for the 5Ks, all the way up to the storage array that, as I said, is connected via a 1 gig interface. So now that the server has stopped, I'm going to boot the server and let it come back up. And rather than making you guys wait to see what's happening, what I'm going to do again is I'm going to pause the video while I'll come back in, and we will take a look and see what happens to see if the installation media discovers the target located on the iSCSI array. And remember, we completely deleted all of the virtual host bus adapter configs. So I'll see you guys when that time comes. Alrighty. What we see now is that it's gone through the installation process. I'm going to go ahead and hit enter, and hopefully we should be able to see something here real soon. So let me get on the console here, and F11 should tell me what media I have to install on. So I'll hit F11. We'll wait for it to scan for all of the available drives, and hopefully we should see 2 physically attached drives. I think they're Fujitsu's, and they are. And also you can see down here I have pod 1 Z-Vault target. So this illustrates beyond a shadow of a doubt that the iSCSI boot process is working just like the fiber channel process. Just to keep in mind, the mechanisms with regard to transport are completely different. We'll delve deeper into this and other concepts in our UCS Zero to Hero course. I'm Terry Vinson with Micronics Training, and I hope this was helpful, and I hope it took some of the fight or flight out of working with the UCS B series and the UCS Manager. So I'll see everyone hopefully in a class. Till then, take care and peace.